Today we are going to interview a famous designer, Philippe Block. The perfect combination of computational design techniques and theorems used in his architecture, while maintaining the original materials for putting. He breaks the limitations of the original structure. His architecture is a historical breakthrough in structure form, materials, and shapes. This is our famous architect, Philippe Block. Hello, Block. Can you say hi for our audience?
Hi, guys.
I'm so glad to see you today here. I know you're some construction and design. They're all really amazing. Can I ask some questions that help us to understand more details about you?
Yeah, sure, no problem.
Our first question is, what kind of techniques and theories do you use in your architecture design?
Thank you, guys, to inviting me today, and it's my honor to be here. And so, I utilize the modern technology, software, and digital fabrication tools to explore historical construction techniques. My application of modern technology, including parametric modeling, its application is to produce smaller, stronger, and more sustainable buildings and component with less material, money, and time. I use trustworthy network analysis to explore different assumptions on the fourth floor in vaulted masonry. The main advantage of TNA that's faster and easier to investigate complex networks. The extremely fast computation, the new solving algorithm, we can get practically real-time feedback for each false pattern drawn and generate, which allows me to check many false floor assumptions rapidly. Through the use of TNA framework, it allows me to find the best fit truss networks for masonry vaults with complex geometries.
So the next question is, how do you utilize contemporary digital computational technology to explore historical construction?
The new computational form finding and optimization approach for exploring three-dimensional equilibrium shell structure based on the stability analysis of Gothic masonry vaults. The intuitive graphical method allows me to gain control over the exploration of form, which allows for the design of vaults with little or low quality material, or the design of efficient and expressive service structures. And also, we develop a computational framework that contains several flexible data structures, novel and efficient solving algorithms, with numerous nonlinear optimization and solving procedures. This allows us to develop new solving strategies, allows for equilibrium problem, often significantly improving solving times and compared to existing approaches. Ultimately, the computational methods developed have led to novel structure typologies and structures design approach for highly efficient expression form. They have enabled the extension of our expertise in compression-only problem to other structure systems, such as thin concrete shells, bending active membrane structures, fabric floor systems, and the journal spatial system of floor space application in building design and large span roofs. So your design masonry walls in 2014 with complex geometry without foam wall. How do you make masonry does not lie be possible? I developed force diagram to map out the truss network of the historical wall are simple or not balanced in compression, a concept that applies at any scale. So it's possible to test in small models and anticipate that what happened when the scale of the building, pushing structure models to collaborate is always fun, but more importantly, it's very educational. Masonry doesn't lie. I see far-reaching implication for masonry bolting, and also believes it could lower construction costs and structures. In many countries, timber and reinforced steel are not locally available, but there is plentiful and can be molded into masonry units. And I try to achieve greater span than many other types of construction while using less materials.
So the last question is, why were you exploring these structure techniques?
The tile vault is inexpensive to construct. It requires very little formwork, and if it has a well-designed shape, stress are low, allowing the use of locally available materials, such as non-fired soil bricks, to minimize the carbon emission of the entire building process and reduce the need of import large amount of expensive materials such as steel or concrete. For example, the Project Red Line, we designed it for medical and emergency use in Africa, with its two for compression only for finding. We developed a masonry shell that are not only address the structure and the construction requirements for a safe building, but also supports the architectural concepts defined by Lord Foster. The structure is designed such that stressed uniformly by its own weight and has significant double curvature to be stable in compression under all other loading conditions. In addition, because of the geometry of the opening concrete module, create a continuous and smoothly undulating surface.
Now, did you know more about Philippe Block? I believe everyone has deep understanding about his architecture and also the importance of computational design. Through this video, I hope you guys get more professional knowledge and also has more interest in the ideology of architecture. Thank you for watching. Bye.